Hey boys and girls, so today we're going to be going over Unit 3, Lesson 9, which is a sequence of rigid motions. First thing we need you to do is put your name at the top of the page, so that way you can earn credit for today's lesson. All right, so let's start off by reading the do now. It says in each pre-image/image combination below, identify the type of transformation. So this is the question, so I'm going to just underline that right here. So when it's asking you to identify the transformation, there's 4 transformations that we've learned of so far. The first one is a reflection, just like in a mirror, okay, things are reversed. The next one would be a translation. A translation just moves or slides an object. Next would be a rotation. A rotation we know just turns something. And then last but not least would be a dilation. And just like when you go to the eye doctor and you get your eyes dilated, they change size, just like when you zoom in or zoom out on a cell phone. Again, you are dilating there as well. So only 3 of these are rigid motions. It's going to be the first 3, but technically there are 4 transformations. So when I look at number 1, it's telling me that I have a pre-image and an image. So how would I get from, the left to the right? I mean, for me, it looks like it would be a rotation. So number 1 is rotation. It looks like I'd have to turn that first object so it would map onto the second. Number 2, how would I get from the top to the bottom here? This looks like a translation. It looks like if I take the first object and I just slide it over, right, I move it over, they're gonna map on top of each other. If I look at number 3, that also looks like a rotation. It looks like I had a building and then it kind of just tipped over, it turned. So this would be a rotation as well. And then number 4, again, this would be a reflection. I can see how I would get from figure 1 to figure 2. It looks like I would just flip on over there. This would be a reflection. Okay. Now underneath, let's get started on the guided practice. So as we read part A, it says determine the length of each side of the polygon graphed below. So this is really nice because it's graphed on graph paper, so I can easily count the boxes to see how long each side will be. So if I look at the top, I'm going to start at the top corner. I'm going to go over 1, 2, 3, 4, 5, 6, and I'm just going to label it on my diagram as 6 units long. Then I'm going to go down, 1, 2, 3, 4, 5, 6. Again, I'm getting 6 units long. 1, 2, 3, 4, 5, 6 again. And then last but not least, 1, 2, 3, 4, 5, 6. So part A, determine the length of each side. We did that, we are done. Part B, it says, what is the name of the polygon? And we have to explain how we're getting our answer. Well, I know that one shape that has all sides being equal would be a square. So let's fill that in. I'm going to say that it's a square. And how do I know it's a square? Because we just said all sides are equal. But what else do you know about a square? All the sides are equal, and what do we know about all the angles? You got it. All the angles are 90 degrees, so let's fill that in as well. And we also know that all the angles are 90 degrees. And I know that's true because these are all little squares on my graph paper here. So I know this is a 90-degree angle in the corner, this guy, and this guy. So I know for a fact that those are all 90-degree angles. Part B is complete. We named it and we explained. Part C, graph the line y equals x. It says you can use your graphing calculator to help you if you need it. So I'm going to just take mine out and show you how we would type this in. So let me come under the camera here. So I'm going to go to y equals, and again, it says the line y equals x. That's all I need. I'm going to press graph just to see what it looks like so I know if I'm graphing it correctly or not. So now that I see what it looks like, now I'm going to go to my table, second graph, and I'm going to start plotting some of those points. Remember, if y equals x, that means if y is 0, x is 0. If y is 1, x is 1, because they equal each other. So those are some of the points that I'm going to start plotting. So I'm gonna plot 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7. I think we have quite the number of points to get us started here. So if I want to graph this line, I know lines go on forever, so I'm just going to take my handy dandy ruler here. I'm going to line it up nice and careful, and I'm going to draw in that really nice, straight line. Again, lines go on forever, so I'm going to include arrows on both ends. So again, part C said graph that line. We graphed it. We are now done. And then part D, it says, is the line considered a line of symmetry for the polygon graphed? I'm just going to highlight that quickly because that's a key word that I should be thinking of, a line of symmetry. If something is symmetric, think of your face. If I were to cut my face in half, and I don't mean literally, but if I were to take, a ruler or something and run it down the middle of my face, I'm gonna see the exact same thing on both sides. I have an eye on the left, an eye on the right. I have half a nose on the left, half a nose on the right. So when I'm, again, like running, let's say like a ruler down the middle of my face to, again, like kind of cut it in half, everything that's on the left should be on the right. It should look exactly the same on both sides. So here, if I were to take this square and I'm cutting it in half, I can see this side is 6 and this side is 6. It's the same thing on the other side. This side is 6 and this side is 6. It's exactly the same. If this angle is 90, this angle is 90, right? So on and so forth. Another way would be, again, like thinking of the folding in half method. If I took a piece of paper and I folded it in half, if it's lining up perfectly on both sides, that means that it would be symmetric. So for example, if I were to take, let's say like a Post-it, here's a Post-it. If I were to fold it in half, I can see that both sides are lining up perfectly. So when I open it up again, this crease in the middle would be considered a line of symmetry, all right? Because it's right down the middle. The same amount that I have on the right-hand side is the same amount on the left-hand side. All right, so here we go. It's asking if that line, is that a line of symmetry? We would say yes. So let's fill that in, yes. And I know it's a line of symmetry because the square can be mapped onto itself. All right, and again, that really means that it can be folded right onto itself, and it's gonna look the exact same on both sides. Okay, let's flip to the next page. All right, so we have some guided practice here, so I'm gonna walk us through what exactly we're supposed to do. It says in each combination of figures below, the pre-image is located on the left. Let's highlight or box that. And the image is located on the right. Describe the rigid motion that's gonna map the pre-image onto the image. So I'm gonna underline the question here. We have to describe the rigid motion. Well, there's only 3 rigid motions: rotation, translation, and reflection. That's gonna map my pre-image onto my image. If they're telling me the pre-image is located on the left, I'm gonna label that right now as a first step. So this is my pre-image, this is my image. This is my pre-image, this is my image. All right, pre-game, that's before the game, right? So this is where I'm starting. Image, that's the game, that's where I'm ending up, so that's where I want to be. All right, so I need to move somehow from here to here, and then again, I need to move somehow from here to here. Now, as I look at the first example here, for me, it looks like it's going to be a rotation. I know that in a rotation, orientation is preserved. That means it's the order of the letters. So if anyone's confused if it's a rotation or a reflection, you can always check the order of the letters. You can check the orientation. So if I'm moving from A to B, I can see that would be a clockwise like rotation to get from A to B here. okay? If I were to move from S to T, again, that's a clockwise rotation. So the orientation from A to B and the orientation from S to T is exactly the same. So I know for sure it's a rotation. It would have been different if it was a reflection. So if I know that this is a rotation, one of the first steps is going to be for me to connect two pairs of corresponding points. Now, I know that S should eventually map on to C, so I'm going to connect S to C. And then I'm supposed to create a perpendicular bisector because that's going to help me find my center of rotation. Since I know this is a rotation, these are the steps I would follow to describe that rotation. First step, connect one pair of corresponding points and draw in a perpendicular bisector. So I'm going to line up my pointer on S. I'm going to make sure it's nicely in the middle. And I'm going to move my slider so I'm not all the way to C, but I'm pretty close. I want to be like 3/4 of the way. I'm using my inside hole, so I'm going all the way up and down. Now I'm just going to turn my compass around, turn around. Okay. And then I'm going to make sure that my pointer is now on C. And again, I want to use the inside hole. So I'm going to swing up and down until my arcs are crossing like so. Then I'm going to go back one more time, and I'm going to literally draw in my perpendicular bisector. I connected the arcs, call it a day. Now I'm going to turn my paper back. I have to draw in a second perpendicular bisector. So now I'm going to connect another pair of corresponding points. Now, I could do B to R, that's fine. I could do D to T, okay, that's fine, right? I know these correspond, they're in the little crevice there. Or I could do A to Q, because again, that's far away, far away. I know those correspond. So for me, I'm just gonna do B to R, but I could have done D to T or A to Q. It doesn't really matter. So again, I'm gonna connect B to R. Those are my corresponding points. I'm going to put my pointer on B. I want to line it up nicely in the middle. And then again, I don't want to go all the way to R. I want to go maybe 3/4 of the way. So I'm using my inside hole. I'm going to swing all the way up and down. And then I'm going to turn around. Okay, I'm going to make sure that my pointer is now on R. And again, I'm using my inside hole. And then I'm going to go and connect my arcs with that perpendicular bisector with my straight line. Okay, I can see that my first line is in blue and my second one is in purple. I have to see where those lines are crossing. So let me actually grab one more color. Let me get like a red pen here. So I can see they're crossing right around here. So this is where my center of rotation is going to go. And because I'm adding it on, I also need to label it with a letter. And I have to make sure I don't pick a letter that's already in the diagram here or here. I'm going to pick the letter O just because I know it's not there and I'm safe with that letter choice. And now I'm ready to describe the rigid motion. So I'm going to say, let me grab my pen again, that this is a rotation about point O. So I'm using the vocab word. I'm talking about my center of rotation. That's where I'm rotating around. And now I have to say how far I'm rotating. So I want to rotate until angle A maps onto angle Q. Because I know A and Q correspond. So when I'm turning, A should eventually map up here onto Q. All right. I have to start with A because A is my pre-image. That's where I'm starting with A. And Q is where I'm ending up because Q is my image. That's where I'm going to end off. All right, so that was one. Now let's look at number two. Number two is actually pretty simple. I can see that I just need to take my pre-image and slide it right down, and it's going to map onto my image. So when I'm thinking of a slide, or some type of move, I know that that's going to be a translation. So I'm going to start off by writing the vocabulary word. It's a translation. And when we talk about translations, they move along a ray. So I'm going to say it's a translation along ray. That's the symbol for ray. And now I have to find corresponding points. I'm going to pick N and U just because N is at the tippy top of the first guy, U is at the tippy top of the second guy. So I'm going to literally draw in my ray because, again, I'm moving from my pre-image to my image. And again, I want to move from N to U. N is where I'm starting, U is where I want to end up. All right? Your job right now is to try the independent practice on your own. Again, utilizing what we just went over a second ago, and check back in, I don't know, about 5 or 10 minutes when you guys are done. All right, guys, so as we look at the independent practice here and we read the directions carefully, it says in each combination of figures below, the pre-image is located on the left and the image is located to the right. And then the question asks us to describe the rigid motion that's going to map the pre-image to the image. So again, if I know that my pre-image is located on the left, you could have definitely gone ahead and labeled that. So let's do that now. Here's my pre-image. That's where I'm going to start. Here's my image. This is where I'm supposed to end up. Same thing on number 2. On the left is my pre-image. I could have labeled this to start. And on the right is my image. This is where I want to end up. So as I look at number 1, I have to identify what rigid motion was taking place, and it's a rotation. This looks like a building that kind of fell on its side. It looks like it turned. A turn is a rotation. Where am I rotating? About point H. So H is my center of rotation. And where should I turn? Where am I going to end up? Well, I'm going to turn until angle A maps onto angle R, because angle A and angle R correspond. This is at the top on the left. This is also at the top on the left. All right, that was number 1. And then number 2, as I look here, this was actually a reflection. So whenever I'm reflecting over a line. So in order for me to find the line of reflection, I had to create a perpendicular bisector, just like we actually did up top a minute ago. So the first step is to connect one pair of corresponding points. W and M correspond, so I drew a line segment connecting them. And then again, I have to make a perpendicular bisector. So I got my football here, I went more than halfway, swung, turned it around, swung again, and found my line. All right, just like in a rotation, once you find the center, I need to label it because this is something that I'm creating here I labeled that as O. Down below, it's the same thing. I had to label this line with a letter. I just chose to label it L. I see that L isn't in the problem anywhere, so I'm good to go. So it's a reflection over line L. And if you want, you can highlight it out. It just becomes even clearer to see that where your line of reflection ended up is correct, because I know these points that correspond should be equidistant from my line of reflection. So I can see that S is about maybe, an inch away, T is about an inch away. Same thing, D, and then to H, all right? They all look equal distance from that line of reflection. All right, last but not least, final page. So as I'm looking here, again, this is a guided practice, and it's telling you to use a compass and a straight edge to describe a sequence of rigid motions that's gonna map quadrilateral. Quadrilateral is just a 4-sided shape. So I want to map AUQD onto A triple prime, U triple prime, Q and D triple prime. All right, so here's my pre-image because there's nothing on it. Woo, and here's my triple prime all the way down here. So this is where I'm starting and this is where I need to end up. So I got a lot of stuff to do here to get that answer. All right, a lot of moves, making moves. So as I look at my pre-image, how would I map this left quadrilateral onto my prime quadrilateral? All right, this is going to be my first transformation here. So I can see U to U prime. A to A prime, D to D prime, right, and Q to Q prime. This looks like it's going to be a reflection to me. So we actually just went over a reflection on the last question. First step is to connect one pair of corresponding points. So I'm going to connect Q to Q prime. All right. Now I have to create my football. I got to get that perpendicular bisector in there. So I'm going to put my pointer on Q, make sure it's lined up nicely in the middle. And then again, I want to extend my slider about 3/4 of the way. So again, I'm going to use my inside hole. So I'm going to swing all the way up and all the way down. Now I'm going to turn around, and I want to make sure that my pointer is on Q prime. Make sure it's lined up nicely. And I used my inside hole before. That means I got to use my inside hole again. Here I go for the swing, and then I'm going to go and connect for that line of reflection. Now, if you remember from a minute ago, I have to label that line of reflection. I don't see L anywhere, so I'm going to label this as line L. And then if you want to, I always just like to highlight out my line of reflection. Just looks nice. And I'm done. So at the bottom of the page here, I'm going to start listing all of my transformations, or really my rigid motions that are taking place here. So in blue, number 1, we said it was going to be a reflection. And again, you're always reflecting over a line. So this was a reflection over line L. That's my first step. Number 2, now I got to ask myself, well, how am I going to get from my prime to my double prime? Well, it looks like the orientation stayed the same. I should have probably said that on the first example as well. I can see here that the orientation from A to U on my pre-image, A to U, is moving clockwise, and my orientation on the prime, A prime to U prime, is counterclockwise. Since it's different, I know that this has to be a reflection. That's the only rigid motion that does not preserve. That means it doesn't keep the orientation the same. All right, so that's another way I knew that was a reflection. So here, it looks like pretty clearly that I'm just gonna take my prime and just whoop, slide it down to my double prime. So if I'm sliding or just moving, that's a translation. So number 2 would be a translation. And we're always translating along a ray. So here's my ray symbol, that little hat, and I'm gonna put some letters underneath in a minute. I'm gonna now pick, let's do D. So I'm gonna draw a ray from D prime to D double prime. I gotta put arrows on the sides because I'm moving from D prime to D double prime. And that's the answer I'm gonna put here, from D prime to D double prime. I could have went from A to A, U to U, Q to Q. It doesn't matter. That's just what I picked as D. And now last but not least, one more. I have to move from my double prime to my triple prime here. So now I'm hoping that this again might be a little clearer, that this would be a rotation. It looks like they took this guy and just whoop, turned him around here. And again, I know rotations preserve orientation. It keeps it the same. So again, A to U, whoop, off camera, A to U. Let me slide back down here. A to U is now moving counterclockwise here. And again, A to U is also moving counterclockwise. So I know this couldn't have been a reflection. It has to be a rotation. So one more time, if I want to rotate, first step is to find my center of rotation by connecting corresponding points and creating a perpendicular bisector. I'm going to connect D to D prime, I'm lying, D double prime to D triple prime. And I'm going to create a football. Here I go. Again, I'm going to go about 3/4 of the way. I'm going to use my inside hole, swing up and down, turn around. Okay, put my pointer on D triple prime, swing again up and down, and literally draw in my perpendicular bisector. Now, on the last question, where we had to again identify the rotation, I'm using colored pen, So it's clear for me to see where the lines are gonna cross because I'm using two different colors. Now, if you only have a pencil at home, this is another method that you can use. If you have maybe like a highlighter, hopefully, I would just highlight those perpendicular bisectors. As you're creating them, it makes the problem so much easier to see where they're gonna cross. All right, so that was one. Now I'm gonna do another. Let's do Q double to Q triple. So I'm gonna, again, connect them with the line segment. I'm gonna make my perpendicular bisector. Again, I don't wanna go all the way. I wanna go about 3/4 of the way. Turn it around, line it up nice and neat. Again, swing. And again, I see my blue crosses up here at the top and it crosses down here at the bottom. So I'm gonna connect for my perpendicular bisector. And then I'm also going to highlight it out with a highlighter. So again, if you were having any issues seeing where they cross, hopefully it's a little bit clearer now. So I can see it's right here. I'm just gonna grab a different color so it's clear that that's my center of rotation. So I'm noticing here that the letter O isn't being used, so I'm gonna label this with an O. And then last but not least, I am going to write down or describe that rigid motion. So we said it's gonna be a rotation. That's my rigid motion. I have to say where I'm rotating. So I'm rotating about point O. I just labeled it. And then I also have to describe where I'm rotating until. I want to rotate A until I reach where, all right? So again, I'm gonna rotate until angle, let's pick a different letter here. I know we picked D before, let's maybe pick U. So I'm gonna rotate until U double prime, because this is where I'm starting, ends up at U triple prime. I want it to maps onto angle U triple prime. All right. If you guys have any questions, feel free to message us in Canvas. There's no homework for this lesson, so you only need to upload the notes. All right, have a great day, guys.